So I'm going to introduce the laboratory for testing of optical sensors at the Academy of Sciences at the Physics Institute. So it was established rather recently in 2016 related to the LSST project, which now is at Vera C. Rubin Observatory. And the purpose was testing CCD sensors. Some of the equipment at the beginning was related to that, but since the laboratory grew and now we are involved in many new projects. Here's a small photo of what this mess, how it looks today. We have a couple of different pieces of equipment, some of them I would say unique. What we do, first we were doing these studies for LSST, for example, sensor effects and how to remove them. This is example of the so-called three-ring effect on CCDs, where you can see remnants of how the crystal grew when from which the CD was built. These three rings are basically the same as on a tree, as it grows from the center to the sides. The different regions where slightly the chemical composition changes, and you can see it actually in the images. So we analyzed this for the LSST collaboration, and we provided ways how to mitigate these effects. Then we test other cameras, mostly more modern CMOS technology. This is example what we did on this Andor Marana CMOS camera, where we tested many aspects, but one I pointed out here is that as it transitions from high gain and low gain amplification, there's a jump in noise and linearity, which again can be offline corrected, but you have to know about it. So then Czech producer of cameras, Moravian Instruments. Again, this is a study of linearity as a function of the signal, where these cameras are heavily used by other group in our institute, and they're actually installed on different astronomical sites. This one is a picture from Argentina, where there are two of them actually installed. One is a CMOS camera, and the other one on this stand is the older CCD version. So we have them in the exact same environment, and we are able to compare the performance of the two cameras. I'll quickly go through another project, which is the FSUA unit for the LISA mission. Jirka already mentioned the LISA mission. What this FSUA is a mechanism which is supposed to switch between the main and the backup laser, which poses additional challenges to what would be already challenging project, because LISA has very strict requirements. This thing is supposed to sit there for a couple of years and then, if something goes wrong, move, which can introduce another problems like cold welding in vacuum and so on. So due to the requirements of LISA, the way of moving this is the so-called piezo slipstick mechanism. We are currently developing this. We are trying to make a lightweight, reliable version with a low power consumption and a lot of redundancy, as required in almost all space missions. And we need to test also the other aspects like this cold welding. So we developed this Coldwell test stand, which actually I have here a drawing, but it's already sitting on David's desk. He's assembling it, which will go in our vacuum chamber, and we will try to see if the materials we chose will stick to each other or not, hopefully not. Another project we are involved here, you can see a picture of the telescope which stands on the grounds of the Astronomical Institute in Ondřejov. It's a novel telescope with a camera consisting of silicon photomultipliers, and we are involved in calibration of these. So this brings me to my last slide to conclude. So we have a lot of equipment in the laboratory for these testing of these optical and optomechanical components. We are shifting now, or we are already involved in projects for space, which involves testing at extreme conditions. For this, we use the cryo chamber, where we are able in vacuum to cool the thing or cycle it. We are also able to shine light on it through the wide windows. We have various light sources for this and a monochromator to choose the wavelength lasers, calibrated sensors to know what we are sending there, and the usual optical equipment on the optical table, which is, of course, vibration isolated, and the vast set of electronic test equipment you have probably in your laboratories as well. So this was hopefully an introduction of our laboratory. If you have any questions.